name is Brian Schnepp. I'm a combined BS/MS student here at the University of Utah, and my main interests are in software programming for things like embedded systems, general systems programming, high availability, and distributed computing. So my primary interests are in operating system development specifically, but also for things like compilers and work a little with software verification and these sorts of areas. I'm hoping to be able to work with these sort of areas in the future, and hopefully there's a bright future in this area.
Hello, my name is Forrest Jones. I'm currently finishing up a bachelor's in computer science here at the U. I'm fascinated by lower level programming, hence our final project, AdvancedStudio. Through college, I've gained experience with game development, VR, full stack web, and desktop applications, and my favorite language is C#.
I'm Jicheng. I have been at the U for 4 years and have been working on this final senior project, that is very interesting project to work on. As studying at the U, I'm interested in database analysis, network security, software developing, and maybe game developer in the future.
AdvancedStudio was created to fill out a specific problem in mind about how can we get people to be interested in working with low-level and bare-metal software, while also being really simple so that we're not going to overcomplicate things or make things too intimidating for people. As such, targeting an older game console, which doesn't have an operating system in the way, is ideal for this sort of thing because there won't be issues with having a BIOS incompatibility or trying to get software loaded or any of these sort of issues, while also having a very simple hardware platform that a single person can probably understand the entire platform. So as such, we chose the Nintendo GameBoy Advance because of its simple architecture, its primary and processor being very similar to modern microcontrollers, and its overall simplicity for software development with existing tools and libraries. As a benefit of its primary CPU being the ARM7 TDMI, tools like GCC that are already widely used are also still available and still support the ARM7 TDMI processor within the GBA. So we can reuse a lot of these existing tools and libraries and bring them together in one cohesive environment that makes it very simple for people to get started with it. So AdvancedStudio really helps and aims for students to go and be able to create their first title or first project with low-level hardware by making it super easy for them to go and compile C code for the GBA. So we include a code editor here, which allows you to go and see syntax highlighting and language themes for it, so that you can make sure that you're using keywords properly or that certain things are highlighted when you intend them to be. We also include a debugger so that you can make sure that your code is doing exactly what you intend it to be, so you can set a breakpoint within your code and run within an emulator and make sure that your array actions are valid or that your other things are working as intended. We also have asset support, so you can go and use a sprite editor and a tile map editor to create your art assets, and we go and load those in the game as well. So you can have dynamic backgrounds, you can have characters, and you can have sprites as you would see in a real game. And we also include AdvanceLib, which includes support for making these sort of things all gel well together. On top of this, we also include a validator, which is this tool analogous to Valgrind to make sure that you're not doing things like doing a null pointer dereference, or you're accessing bad memory, or you're accessing memory that doesn't actually exist. And we also include plugin support. So if you don't like our default themes, or if you don't like the way we're supporting languages, you can always change and extend it by yourself.
Now we're going to show you a quick demo of how AdvancedStudio works. We're going to do this by creating a very simple game from scratch using AdvancedStudio. To get started, we'll do File, New Project. We'll give it the name, Simple, and we'll quickly give it a folder for it to save and hit OK. This starts us off with some simple code here, and I'm going to replace it really quick with some code that does a little bit more. So this code here is using AdvancedLib. This is a library that we have created for working with the GBA, and this is much easier to use than existing libraries that are out there. As we can see, we're creating a game object here and setting the sprite for the game object. Then we're creating a background and setting the sprite for the background. Then we're creating a game and adding the game object to the game. And finally, we're running our game using our update method. And then in our update method, we're simply getting the player, and then we're checking to see if you're pressing one of the D-pad keys, and we move the player around on screen. We can't run this game quite yet because we need a sprite and a background. So let's go ahead and make those real quick. To create our sprite, we'll go ahead and right-click on the sprites folder, say New Sprite. You can give it a name, Player, and we'll leave it as an 8x8 sprite. You can now use the tools on the left to draw the player. To create a background, we'll go ahead and create a sprite for the tile set, and each frame in this tile set will represent a tile in our background. Finally, we can create our tile map and use our tile set for the tiles. Now that we have our background and player finished, we can go ahead and hit play and see our game running in a Game Boy Advance emulator. And we can see our player moving around on screen. I would also like to note that the ROMs produced by AdvancedStudio and using AdvanceLib are completely valid and run on an actual Game Boy Advance. So we can see that here. I have a flash card plugged into my Game Boy Advance with an SD card, and on the SD card is our game that AdvancedStudio produced. And we can go ahead and start this up. And it's a little hard to see on camera, but you can see the green circle moving around, which is our player.
So our utilized technologies are Qt and C++. We support Linux and Mac OS primarily, but we also have builds for FreeBSD. We use the CMake build system to make sure our project compiles and handles all the dependencies and subprojects we have. And we also use Lua for plugins. So if you do not like our themes or you don't like the language support we provide, you can always add your own. That's cross-platform with Lua. We also use the Lua and JSON library in order to handle project files and project settings and these sorts of other associated details of projects. And we use GDBMI in order to communicate with GDB, so you can use a debugger along with an emulator in order to make sure your code works and test out some various features of it. For CI/CD, we use Git and GitLab. We use GitLab CI for things like making sure the project builds for all platforms we support and actually producing those builds. We use a version control system, which is for Git, and we have about 300 commits for our project and over 129 issues. For our CI system, we use Docker to make sure that our builds are reproducible within platforms. So you can download a Docker image and build it. That's done internally. And we make sure that it builds for Mac OS and Linux and FreeBSD using the system. So for the internal products for the libraries, we use some other associated projects that are about smaller. We use SDL for having a standalone version of our validators, so that if you want to go and check your ROM as invalid memory accesses, you can do that standalone through that. We also use Dynamic for that, so that it's slightly modified and tweaked to go and work with an ARMv4T processor inside the GBA. We use CPP codec in order to handle a couple of those issues with how we actually encode data and send it to the GBA and handle with project files. And we use the Lua and JSON library for that as well. And for our actual Git integration, we had a terminal built in, and that is provided by Qt Term Widget. And we included a whole bunch of tools for the LXQT build environment for that as well. After all of this engineering effort, we believe that we have built a sufficient solution to the original problem presented. By building a complete tool which scales from the inexperienced software developer comfortable with inline assembly, C, makefiles, and other development processes required for something like this, and up to a sprite artist with a little bit of familiarity with programming in general, but not too much, every person involved with the development of a complete game project has some ability to use AdvancedStudio to achieve their own desired goals. Helping developers create games for such a game console, we hope this experience inspires our user to go on further, be it to create games for different platforms, to go and create more expansive worlds with their own design, and explore microcontroller programming so they go on to help them create new programs that help control cars or radios or televisions, or to refine the skills as a digital artist, creating new art assets for the next digital experience that everyone can enjoy. We hope that you've enjoyed this demonstration, and this brief video helps show how much talent and effort is truly required to make this endeavor succeed.